Okay, one last video to wrap up these notes, and we're going to set you loose on a homework here. So what we're doing is we are looking at some situations and seeing whether or not these situations are 50-50. And then if they're not, establishing what the probabilities are. Okay, so flipping a fair coin, heads or tails. Okay, so ask yourself this: why do we do that at the beginning of sporting events? If it wasn't 50-50, there'd be no reason to use a coin, right? The idea is the coin is an impartial random number generator. And dice and cards and coins and things like that, things you see in Vegas, slot machines, they are random number generators. They generate random values. A coin generates two. Now, they're called H and T for heads and tails, but it's really just 1 and 2. You saw in the video I used a random number generator in Excel to simulate a die. So, yes, a coin is 50-50. Half the time it flips heads, half the time it flips tails. Okay. Picking a card from a deck. Red or black. Okay, so a poker deck of cards. I've got one right here. A poker deck of cards, in case you're not super familiar with what a poker deck of cards is. It's 52 cards. Okay, and those cards, I don't know the historical context of this. I'm sure it's got a cool one. Those cards are broken up in a number of different ways. For example, that card right there is a 10. It's got 10 things on it. It's a 10 of diamonds, so it's got 10 diamonds. That's a 6 of diamonds, so it's got 6 diamonds. Here's a king of spades, so it's got a king and spades. So basically, a deck of cards is 52 cards, and if you, I'm going to shuffle them here and then kind of scroll them out so you can see them. It might be kind of hard to tell. I'm not much of a poker player. 52 cards, 4 suits. I'm going to take a look right here. Diamonds, that's one of the suits. That's one of the shapes that are on the cards. Hearts, that's another suit. Spades, ace of spades, right there for you Motorhead fans. And clubs, there we go. There we go. So 4 suits, and those suits are spread evenly through the cards. Now, if you notice as I was going by, the diamonds and the hearts were red, and the spades and the clubs were black. So that means that picking a card from a deck off the top, that card has a 50% chance of being red and a 50% chance of being black. If I shuffle it up again, goof it up around, we're talking about just pulling the card off the top of the deck. We're going to talk about what happens if you keep pulling cards later in this course. I'm sure of it. Okay, so now I shuffle it up again. So once again, 52 cards. Got the ace of clubs that time, so it's 50% of the time, if I repeat that experiment of shuffling the cards and then pulling the card off the top of the deck, 50% of the time I will pull red cards, and 50% of the time I will pull black cards. What do I get this time? 3 of clubs. Okay. Same deck of cards, but now what's the chance I get a club versus not getting a club? All right, so if you did that math earlier, I mentioned that there were 4 suits: hearts, diamonds, clubs, spades. 52 cards spread evenly amongst those suits would mean there are 13 each. So in this deck, I'm going to pull the clubs out real quick. There's a 5. There's a 4. 6, king. I'll be with you in a sec. 2, queen, ace, 9, 8. How many more do I have? 10, jack, 7, 3. Now, if you were keeping track, that's 13 cards. 13 clubs. The other 39 cards are everything else. So, in other words, here is the chance of me pulling a club off the top of the deck, and here's the chance of me pulling a not club, anything else. So there's only a 25% chance of pulling a club out of the deck. 13 out of 52 total. Okay, so that's our first asymmetric probability. Well, that's not entirely true. We saw some of those earlier, but here. Driving your car. Okay, here's where it gets fun. Driving your car. Getting a flat tire or not when you're driving to work. Here's a phone. Okay, so you're either going to get a flat tire or you're not. So if you're not familiar with the idea of probability, you might say it's a 50-50 proposition. But it's not. things are only 50-50 when both things happen at the same rate. I don't think anybody watching this video, and hopefully nobody anywhere, is getting flat tires at a rate of 50-50. I mean, imagine if you did. Okay, I'm going to work, babe. You get to work, you call home. Okay, I didn't have a flat on the way to work. Probably gonna have one on the way home. Like, that doesn't make any sense, right? For years, I've offered this example. There's a crosswalk at COCC I walk across every day and back. I've been doing it for 20 years. It's the one right across from Mazama. If you know the Bend campus, it's right by Mazama. So I walk across that crosswalk, and then at some point in the day, I walk back. I've done it every day for 20 years of working here. Okay. What's the chance I get hit by a car in it? Well, it can happen, right? Is it 50-50? Sweet Jesus, no. Because that would mean I'd be getting hit on average every other time. So what is the chance of getting a flat tire on the way to work? Okay, so I'm going to puzzle through this with you a little bit. I don't drive to work, I bike to work. Well, for y'all, I have to drive to Redmond because I'm coming from Madras, but most of the time when I teach in Bend, and if I only taught in Redmond, I love riding my bike to Redmond too. Never gotten a flat on the way to Redmond. But let's just do some quick approximation math. How many times do I bike to work over the course of a year? 10 weeks in a term, that's 2 bike rides every day. 2 times 5 is 10, times 10 is 100. So 2 rides a day. I said to work, but I'm going to change the phrasing on that. Commuting. So 2 rides a day times 5 days is 10, times 10 is 100, times 3 terms is 300. So it's about a 300 total round trips. It's actually a little bit more than that. We'll call it 333. I don't know, just to throw some other. Of those, on average, how many times do I get a flat tire riding to or from work? And the answer, I actually know this. It's about once a year, roughly once a year. I had one in the fall. I got a long 6 months to go between now and June. We'll see if I get another one. But it's usually about once a year. I've gotten off scot-free some years without getting any. One year, I never forget this, I got 3 flats in one day. That was an insane day. But usually it's about one a year. So you could say the experimental probability of getting a flat tire for me is about 1 out of 333. Okay? So what does that mean? Well, it means that I can't calculate it theoretically, right? There's no coin I can flip at the rate of getting a flat tire. See, that's what my student was, when they asked, why don't we just always use theoretical? Because in a case like this, there is no theoretical probability. The only way to establish the rate of me getting a flat tire is by running an experiment. Let me bike to work, bike home, bike to work, bike home. Keep track of it. How many times did I do that? In those times, how many times did I get a flat tire? That's the only way. There is no theoretical probability. Well, I just lied to you. I'm sure that cosmically there is, but I'm not allowed to see the coin. So I'm not allowed to see that. The last example here was getting struck by lightning at some point in your life. It's such an interesting one. At some point in your life. 1 out of 15,300. What the hell is that? That's the chance of being struck by lightning sometime. I looked it up from the, what is that? I got the source down here. Hang on one second. It's weather.gov. They actually have a website on lightning strike stats. So I tried to, how the hell do you come up with a probability of getting struck by lightning out of 1 in 15,300? That is definitely not 50-50. Thank God. Half the people in the U.S. shouldn't be getting struck by lightning during the course of their lifetime. It should be a very rare event. That's a pretty rare event. So how do they get that number? And if you're interested, ask me after class. I think I have some ideas where that number came from. But that's the idea. There is no coin. Or if there is, it's some cosmic coin that we're not allowed to see. So that's why you're sitting in Math 105, and some of you are going to sit in Math Stats 243. Statistics are collected from experiments. You need to know things like, what's the chance you get a flat tire? Or, more realistically, what's the chance of this disease in this general population? Or what's the chance of this accident in this general population? What is the incidence of this condition in this population? There's no dice that govern that. But things either get the disease or don't, have the condition or not, break the leg or not. Just because these things have two outcomes doesn't mean that they're both equally likely. And that, my dear friends, is where we'll leave this for today. I will hopefully see you next Wednesday, or this coming Wednesday, I guess now. It's going to be the 17th. I will get this off to you now so you can try the homework. Talk to you soon.